Hello. So, if you're in the drone industry, you know that drones are being used for so many different types of applications. And one of those applications is to actually use drones to document and preserve historic buildings. So, in this particular video, what we're going to do is we're going to walk you through a complete workflow for how a church was actually mapped and inspected using AI and drones. And we're going to walk you through the entire process from flight planning to 3D modeling to AI and reporting. Let's have a look. All right, so what I've got on the screen is essentially the church, the local church that's going to be mapped in this particular video using drones and inspected. And so what you see over here is the south facade of the church. Arguably, it's not very visible because of this tree, and that's actually one of the reasons why it'd be good to use drones to be able to get a better view onto the south facade and to understand what are the different conditions that are developing on this south facade. And also, there's actually an array of solar panels over here. We can't really see them, but there's all these solar panels over here that we want to be able to quickly map and inspect. So let's have a look at how you would do this. So we're going to be using hammer missions for this particular video. And so we're going to actually go and map the south facade of this church. And what we've done in the past is that we've actually already created an output. So what we're looking to create is an output of this nature. So we're looking at the same church, but we've got this particular deliverable now that's been captured and created using hammer missions. So this is the south facade of that church. And it's got all these different labels here. But what do these labels actually mean? And what are we trying to inspect over here? So we'll have a look in this video, but let me walk you through the entire process. So let's get started with flight planning. So when it comes to flight planning, we're going to go into the flight planning or the mission planning side of Hammer Missions. And in this sort of mission planning side, we're going to create ourselves a new mission. So I've got a new mission over here, or a new flight plan called Church Facade. Typically, I just go in over here, give it a name, Church Facade, and then I'd open the file. So I've already got a file set up over here. So I'm just going to go into that file now. And once I'm in that file, I'm going to now set up my flight plan. So let me just get rid of this and start from scratch. So this is a pretty small facade. If you think about it, it's not that large at all. So what you're able to do is you're able to actually go and map this facade. But already you can tell actually the resolution from Google Maps is terrible, frankly. I mean, you can't use this for any kind of inspection. Maybe for some form of measurements, you can use this, but it's not really that useful or usable from an inspection perspective. So we're going to go into our facade mapping mission in Hammer. So you've got this facade mapping here. We've also got a little tooltip if you want to watch a little video on it. But let's go into facade mapping over here. So we choose facade mapping. And once we've chosen that, we can now sort of essentially click 2 points to map the facade. So we've got the first point over here. And let's say the second point of the facade is over here. We do that, we hit enter. And Hammer is going to generate a default flight plan for us, as you can see. And this particular default flight plan, these blue triangles, what they indicate is essentially where the drone would fly and take a photo. And it's going to actually look into the facade as it's taking photos. So for me to be able to configure this, I'm going to go into this little cog icon over here, or the gear icon. If I click that, it's going to open up a settings menu. And now I've got my settings in front of me. And I can go set up my mission. So first of all, you can actually change the metric units. So if you want to actually have this captured not in feet, but in meters, or if you're more comfortable with meters, you can go into this little wrench icon and you can change that to use imperial units or not. So at the moment, we're going to keep this to feet. And essentially, we're going to go into our little gear icon over here. And from the gear icon, I'm back into the mission settings. We're going to be capturing this with a Mini 4 Pro. So you're going to be using a Mini 4 Pro. So we just choose that as the camera type. And as I select that camera type, I will notice that my flight plan changes a little bit and also my GSD changes a little bit. I'll come to what those two are in a second. Flight mode. So what we've got is width first. So what this is saying is that the drone is going to fly the width of the building first, then it's going to drop in altitude and it's going to fly left and then it's going to fly right. And if I wanted to visualize this, I can just click on this play button over here. I click that and it's going to show me how the drone would fly and what the flight path is currently. So you can see over here, I've also got a little 3D view over here that I can actually click on and it'll become bigger. I can see what the flight plan is at the moment, and it's not really configured at the moment. So we need to be able to actually go in and configure it properly. But if I change that to height first, you'll see that the flight plan changes to height first mode, where you're going up first, then left and right, and then up and down first. So it's just a preference really in terms of how you want to fly this. For taller buildings, maybe you want to go up and down first, but at the same time, if you've got a risk of GPS signal, maybe going with first is better. So Hammer gives you both options, so you can essentially go and change those things. Top altitude. So this building is not super tall. So if you go back to our image over here, we've got sort of some approximate dimensions. You can actually estimate this using Google Earth as well. And we've done other videos on how you can do that. But we know from prior knowledge, this height over here is about 20 meters or 60 feet. So what we're going to do is that we're going to go into our flight planning again and change that to 60 feet. Before we do that, we're going to actually change the bottom altitude. So the bottom altitude, we wouldn't want to go lower than, let's say, 8 meters or 24 feet. So I'm going to just change this to, let's say, 25 feet for nice even numbers. Once I've changed that 25 feet, I can change the top altitude, which, as I said, is going to be 60 feet, something around 20 meters. So we've got 60 feet all the way down to 25 feet, and that's going to be our top and bottom altitude. It's advisable to cross-check the flight plan right after. So we're essentially going to be capturing data in 3 rows of flights. So the drone's going to fly along, capture images, fly along, capture images. It's sort of giving us an estimate of only 15 photos at the moment. So we've got to keep adjusting our flight plan. So if I go back to our map view and gimbal tilt. So at the moment, the gimbal tilt is 0 degrees. I will add a small gimbal tilt, maybe minus 20 degrees. And what that's saying is that the drone's gimbal on which the camera is hosted, that gimbal is going to point slightly down. And the reason for that is that when we're flying this facade, we want to be able to capture the lower elevations, even though we're not coming all the way down. And so to be able to actually look at an angle from here will allow us to be able to get all the lower elevations as well. And so that's really helpful. Sometimes you've got trees blocking lower elevations, and therefore you've got this sort of angled flight mode, which can allow you to get the lower elevations. So it's a very similar principle that's being followed over here. Right, so we will be gimbal tilts. We've done that. Horizontal distance. So we really want to get a good GSD on this flight. So GSD is the ground sampling distance, and that's the parameter that controls what's the resolution of the flight. It allows you to really help hone in on whether you're going to get the right detail or not, and allows you to actually understand whether you have the right parameters in place. So at the moment, with our current setup, we're getting 0.6 centimeters per pixel. And that's not too bad, but it's actually a bit low from a facade perspective in the sense that it's actually too high. I know this low and high can be confusing, but lower the GSD, higher the detail. So that's sort of like one of the things you have to keep in mind, that when people say the GSD was too high, they mean that the resolution or the detail on the images will be really low. And so let's go and sort of change this up. So what we're going to do is we're going to fly, let's say, 20 feet from the facade, or let's say 25 feet from the facade. So when we do that, now we're looking at 0.3 centimeters per pixel. And that is great because it allows us to get really good detail. Also, because we are closer to the facade, we're actually just clearing this tree. Now, one thing you have to bear in mind is that the distances and everything on Google Maps can look a bit odd and actually somewhat offset from the real world. So when you go to the site, and we're going to show you some of the site workflow as well, this tree may not be here, and this particular point may not be here either. So what you've got to do is you've got to make sure that actually you're clearing the trees, but you've got to readjust this flight plan on site. And we'll show you how to do that. There are some tips and tricks you can use for that. But let's go for 25 feet from the facades, and let's go for 80% overlap. It's a relatively small facade, so we can afford to have really high overlap. Generally speaking, at least 75% overlap between images is super important. If you're not aware with overlap, it's essentially just a parameter that controls what is the common region between every 2 images. So if I go back to our output, just to give you a sense, if you look at every 2 thumbnails in these images over here, all these thumbnails, as you can tell, they overlap with each other. So for example, over here, we can see the corner of the building. And we can see the corner again, we can see the corner again, we can see the corner again. We see the corner for quite a while, for at least 5 photos before it disappears. And that means that all of these 5 photos have at least 80% overlap. And so overlap is what allows you to reconstruct the building in 3D and create these three-dimensional models that you see on the screen. And so it's really important that if you want to get good level of detail and good reconstruction, that you're actually using a high overlap. So we're going to go back to our flight planning, and overlap is super critical. If you don't get anything else right, getting overlap right is super important. So just please bear in mind that's non-negotiable when it comes to these types of flights. Flight speed, so Hammer will automatically calculate the flight speed for you based on all these other parameters. So if I change this up, Hammer will give me the option to go back to the optimal speed. And the reason for that is that what happens is that when you're flying your drone to capture a facade, you essentially have a bottleneck. And that bottleneck is the camera settings, the camera interval, or the camera shutter speed. You can't actually fly faster than the camera can take photos. It's just a physical constraint. And Hammer takes into account the appropriate camera shutter speed for the camera you selected. It calculates when do you need to take those 2 photos, and it actually provides the optimal flight speed for you. So you don't have to worry about it too much. You can keep the flight speed what it is, and just make sure that if you're flying in windy conditions, you're never really flying in wind which is higher than your sort of optimal flight speed, because the drone's going to struggle. And so really important to make sure you got your flight speed right, and then the physical speed of the wind does not exceed that by a huge margin. So really important. Rotate points 180 degrees. This parameter over here, it only puts the points on the other side of the facade. If for some reason the points were on this side and you wanted to capture the other side of the facade, you could always use that option to just juggle that. Show planned images is not relevant here, and capture multiple angles at the same points is also not relevant for this particular video, so I'm going to not go into that. But yes, once you've got all of this, you can now do a simulation again. Make sure you can cross-check everything that you've set up. So simulation is over here. And now in your simulation, you can see you've got a lot more rows. You've got 1, 2, 3, 4, 5, 6, 7 rows of flights and 119 photos. So maybe that's what you want to fly on site. Maybe you want to change some things around. In this particular instance, we did change some things around, and so you will get a sense for that when we sort of put that on the screen. But in the meantime, what you see essentially is the 3D render of the flight plan and how the drone would fly this flight. So that's all for the flight planning side of things, or at least the desktop-based flight planning side of things. Once you've got a flight plan over here, it's going to get saved into your mission file. So this file now that I've created a flight plan in, it's going to save that mission file. So every time I open it, it's going to show me the same flight plan. That's great. And now I can sync this flight plan with my Android app. So all I have to do is I go into my Android app, which is the Hammer Missions app on Android. If you don't know where to find that app, it's basically available at hammermissions.com/app. So if you go to that particular address, from there you can download the Hammer Missions app, and you can log in with the same username and password, and then you can download the flight plan that we just created onto your smart controller for DJI, or an Android tablet that you might choose to use with other drones, or the Mini 4 Pro, for instance. So with all of that said, now we're going to move into the field workflow. So let's have a look at what happens on site in the field. So we go to on-site side of things now. And so what we're looking at is essentially the drone on site. So now that we're on site, we're looking at the video view of the drone. So the drone's taking off. And the first thing we're going to do is we're going to actually use the drone to mark the 4 corners of the building. Now, why are we doing this? We're doing this because, as I mentioned earlier in the video, there can sometimes be an inconsistency between Google Maps and the actual site. And so that tree that I talked about earlier in the video, that may not be where it looks like it is. And so what you want to do is you want to use the drone, and you want to find the corners of the building and mark the corners of the building. And this allows us to create a 3D polygon on site, which is exact, and using the drone's GPS to be able to actually create the correct coordinates of the building that you wish to capture. So if there is an error in the drone's GPS, it would also show up in the building coordinate systems. And so your flight plan relative to the drone and relative to the building will be correct, even though it might look incorrect on Google Maps. So what we're doing here is that we're just simply flying the drone and we're marking the building, quote unquote building. We're actually just marking a bit of the facade, but you can do this process for the entire building. And once you've marked up the entire building, what it's going to do is that it's going to allow you to create this 3D building polygon. So you see, now we've got a 3D building polygon on screen, and we've got everything 3D. Even the drone icon that sort of indicates where the drone's at is also 3D. And we can tell that we were actually flying at 31 meters, which is 90 feet. So a lot higher than our planned height. But we've been now able to construct a 3D polygon, which is exact, and we can now accurately tell where is that tree. Hopefully you can see my mouse pointer. So we've got that tree, and we wanted to make sure that tree is actually further away, and we're clearing that tree, and we've got the right coordinates when it comes to the 3D building polygon. And so this polygon is going to stay on the screen, and it's going to allow us to actually plan our flights and actually fly with respect to it. So now we're going to go into this gear menu. And in that gear menu, we're going to go to auto plan mission, pick one of the facades we want to plan the flights, and just generate the mission. So this mission was generated on the fly. And we're now going into changing the settings. We're making sure obstacle avoidance is on. That's really important. We're going to change the go home height to 50 meters. Really important to do these checks before you start flying. And we're going to go in and check some of these other parameters are all as we expect. So we're going to check the top altitude, which is 36 meters at the moment. Maybe that's a bit too high. So we're going to change that, and we're going to say 17 meters, so about 51 feet. Bottom altitude is going to go to somewhere between 7 and 8 meters, so about 25 feet. And the horizontal distance is going to be about 8 meters or 24 feet. Overlap, we're going to go for 80%. So we've got 80% overlap, and boom, we've got a flight plan that's ready to go. So with all of that, we're just going to cross-check our settings one more time, make sure that we are capturing with the SD card selected, so all the photos get saved on the SD card. We want to make sure we're not going beyond 75 meters in this flight. All of the different options are correct and look as they should. And let's go fly. Right, so here we are. Mission's uploading to the drone, and we're going to be flying very soon. And boom, we have takeoff. So we can see we have the drone on the map, and it's going to go to its first point, and it's going to start looking at the facade. So it's going to turn around, and now it's going to start looking at the facade, point the gimbal down, and it's going to start taking photos. It's going to create this sort of shutter noise. That's going to show you that it's actually taking photos. As you can see, we've got clearly the different parts of the facade in view. So I'm going to speed up this video so that we can very quickly go through the entire process of taking photos and ensuring that we've got all the data that was collected. So it's going to go through all the different photographs and ensure we've got good detail on that. So one of the things you will find, sometimes the obstacle avoidance will kick in, but all you have to do is just resume the flight, and Hammer will continue the flight planning. So essentially, sometimes DJI's obstacle sensors can get in the way, and they'll give you a false alarm for an obstacle. And so if you encounter that, don't panic, just resume the flight. So it's going to continue. We've done 3 legs of flights so far. We've gone 3 rows. Now we're on the 4th row. It's going to continue. Now we're getting those lower elevations that weren't previously as visible. And we're going to do our 5th elevation at this point, or the 5th row in that same elevation, and going to continue taking those photos. You can see how the gimbal angle really helps and get you all that sort of data in the right place. So we've done all our 5 rows of data capture. Now the drone's going back to its go home position. So that is about 50 meters. So it's going to rise to 50 meters, clear all obstacles, flight is complete, and it's going to go back to our takeoff point and start landing to our takeoff location. And with that, we have all the data captured, and we're going to move into the data analysis workflow. Right, so now that all the data is captured, how do we create a result like this? Well, it's quite simple, really. All you have to do is you just upload all your data into the data analysis tab of Hammer Missions. So you would go in, create a project, and in that project, you'd be able to sort of create all the photographs. So all you have to do is you go in and upload all your data. So if I go in here, let me show you this from scratch. You just have to upload your data, give it a name, your project, and once you've given it a name, you can start uploading all the images. So once you've done that, you can create a file. So over here, we've got the project that was captured. And once you have created a file, what you will notice is that you see something of this nature initially, where you'll sort of see, not even this actually, you will see, let me get rid of that. You will just see all the photos that have been taken, and you'll see thumbnails over here, and all this data then has to be processed. And so to process the data, click on Process Images, select 2D map and 3D model, and you can ignore these advanced options for the moment, and hit Process. And once you've hit Process, it's going to go away and process all that data into a 2D map and a 3D model. And let's say an hour or two later, so this is only 97 images, so it will get processed in under an hour. You will be able to see the 3D model on your screen. So what I've got on the screen is the 3D model of the church that has been reconstructed in Hammer Missions. And this is the power of drone data. I mean, look at the amount of detail you can get with drones. I mean, just compare that to satellites. I mean, satellites don't even get close when it comes to this amount of data, especially when you're looking for specific deficiencies and you're looking to understand conditions and try to do a proper defect assessment. So let me get this well positioned. Okay, so I've got this well positioned. And the first thing you would do is sometimes when you process the data, you might over capture some things. So one of the things that Hammer allows you to do is that once you've uploaded all that data, you can actually go and cut the 3D polygon. So over here, I'm just going to bring up the different sort of cuttings that have been employed. So over here, we can see the reconstruction zone, or the 3D cutting polygon that was used. And this allows us to actually cut away parts that we don't need. So if we don't need specific parts of the 3D model, we can go away and cut them off. So over here, the box has been set around here, but you'll sort of see there's actually more areas that were reconstructed that we don't need. So we can just move the boundaries of this box to reduce or remove what we don't need. So for example, oops, got the box moved too far. Let's bring it back. Back. Okay, so you've got, for example, all this area that you don't need is sort of like junk area, really, that sometimes gets captured. So you can just use the box to actually go away and cut anything that you don't want, really. So if I pull this forward, this one over here, it's going to cut away more. Maybe you want to keep this. Maybe I want to just have a neat line over here. So yeah, it's just a cutting tool that you can use. You can also cut horizontally, but over here in this facade video, we're cutting vertically. So yeah, those are some of the important things to keep in mind. Anyway, once you're done, just hit the tick button and then all that gets saved. And voila, you've got your data. Now, once you have your data, what do you do with it, right? That's the important thing. Like, why are we collecting all this data? Why are we doing all this effort? So first things first, maybe we want to be able to sort of prove that, look, you've got all this sort of dust and potentially bird droppings accumulating on the solar panel. In fact, when we were capturing data, we saw a lot of birds, and maybe that's affecting the efficiency of all these solar panels. And so just to be able to flag that, we can just double click on that point in the 3D model, and then Hammer Missions will bring up the closest photo. And in the photo, you can actually really zoom in and sort of see that. So I can go in and sort of say, give it a tag. Let's just call it bird droppings. And then I write a comment. Something like droppings from birds might be affecting solar performance, something like that, and just hit OK. And now I've got that particular comment and tag saved on that particular box. So what that does is that it allows for that particular comment or box to be seen at any points by someone reviewing this data because that's been tagged. And so all the tagged and annotated images can be actually filtered, and you can always go back to a particular area of concern. And you can filter by different types of tags. So you might have a bird dropping tag that you want to filter by, and you can filter by that, and you can get to this image that we just tagged. Or you can filter by other types of deficiencies and defects. Now, one of the other deficiencies that was interesting over here, as you'll probably notice, is that all of this sort of stone wall, because this is a historic building, going back to our historic buildings, with the stone wall being so old, you can sometimes get all of those sort of stains forming from different water that is running off the stone. And over time, it can cause different types of deterioration. And to be able to ensure that that sort of degradation is not accelerated, and then proper maintenance plans are in place, proper restoration plans are in place, you actually have the ability to be able to go and measure the amount of damage or defects that have been formed because of the different elements. And, you know, a lot of it is rain, but it could be wind, it could be the sun. And so all this staining has now been automatically marked up using AI. So in Hammer Missions, there are AI models that can be used to automatically find some of these different types of defects. So if you want to find stains, you can essentially just use the staining model. So let's go into our stains, and you can use the staining model to automatically find some of these stains. And you can see that over here, different stains, especially the ones on these particular columns, have been marked up by AI. So if I go into any one of these stains, let me just go to A12. Hammer will show me the photograph where that particular stain has been noted. And then from that photograph, I'm able to discern what is the actual condition of the stain. So for example, over here, it's called a dark patch. We've got this dark patch that has been formed over here in this, can be seen in this photograph. And if I go into it, it's going to show me what is the current status of that dark patch. And it's going to allow me to be able to understand if something needs to be done with respect to that dark patch. I can go into sort of other dark patches as well. So for example, if I'm curious about A9 as opposed to A12, similarly, I can just double click on A9 and it's going to bring me that particular dark patch and show me what that looks like. So over here, showing me this dark patch over here. And in fact, it also gives me, you know, it's about 4 square feet in area. It's about 2.8 feet in length, and then it's got 6 feet in perimeter. It really helps sort of understand the 3D measurements of that particular area. So it's automatically measuring all of these different dark patches, these stains for me as well. Because ultimately, if there are defects forming in the particular property, whether it's a historic building or a different building, we want to know what is the extent of the damage or defects that are forming. And knowing that allows us to actually act on that data. And that's the big thing. Drone data is something that you want to act on. If it's just collected for collection's sake and you never act on it, or you never document it, or you never really use it, then it becomes a cost as opposed to a value driver. So we want to make sure that everything that is being looked at is something that is acted upon. And so we've got all the different 3D measurements over here, and we're going to look at the consolidated view. So if I go out of this, and now let's say I want to look at, okay, well, you know, how much of this stone wall on this upper facade over here has been stained? Maybe you want to get some consolidated measurements. And so I go into my AI option over here. I look at the quantification tab and I see, well, we've got 25 observations and we've got 127 square foot of these dark patches formed by stains. And we know that that's sort of covering quite a large area, to be honest, of stone wall. Now, that in itself isn't a cause for concern, but it's something to keep an eye on, and it's something to monitor, because ultimately, let's say we do the scan again, we've got a repeatable flight plan, and we've got a repeatable AI model and a repeatable 3D model. And therefore, we can do the scan again in, let's say, a year's time or in 2 years' time, and we can see how much of the area is now stained. And that just allows us to quantify how much of the damage or how much of the defects is actually growing over time. And we can make preventative maintenance actions in place. And we can also take different types of robust reconstruction, restoration actions in place so that we can actually do something about all these different issues that are forming. Right, so once we've got all of this under our belts, let's create a report from all this data and conclude all of our observations and make them available to different stakeholders. So the first thing we can do is that we can share all this data. So you can bring in other people. So if I wanted to bring in team@hammermissions.com, I can just basically add them to the project. Or if I have other stakeholders, let's just say, I don't know, email at stakeholder.com. Oops, can't spell today. Stakeholder.com. You can basically go in and add their email address, or you can create a link from Hammer and send a link to them so that they can view the project. And because everything is cloud-based, they don't need to have custom software to open the data. It all loads straight into their browser. Even though it's quite heavy data if you think about it. I mean, drone images aren't tiny. All of that data becomes easily accessible to anyone, and that's really democratizing and really making it possible for many parties to actually leverage this data and to be benefiting from this data. The final option here is to create a report. And so what you have to do is that you can go in and you can add your content. So you can choose what you want in the report. Do you want to have all the data, all the images exported, or do you want to export only a certain amount of images? That's possible. You can add an introduction. So over here, once you have the, let's say, an executive summary, you can add that executive summary into the introductory paragraph. And once you've got all of that introductory paragraph included with recommendations, all that will get exported to the reports. You can add a cover image, and we've done that. We've just chosen the best images for this possible reports. And you can go in and you can add your own logo to the report. You can add who the report was created by, and also the title page. So basically, you can brand the report and fashion it the way you'd want to. The footer is just adding your summary paragraph, your address, phone number, page numbers. And one of the most important things, you can actually add links back to the project, back to Hammer Hub from the report itself. So you can actually go and do that, and then that's going to make the project visible via the link. And you can choose whether you want to export this to PDF or you want to export this to Word. And PDF, of course, is PDF. Word allows you to configure and change the content. And one of the nice things about exporting to Word is that now you've got all these different AI tools that you can use to actually export to Word in an even better manner. But yeah, we would normally go in and we would generate the reports. So what we're going to do is hit the generate report option over here. And for the purposes of this video, I've already got a report generated beforehand. So let's have a look at the reports. Okay, so now we're in the reporting section. And so we've got this particular report. We've got the project name over here and the project type. The stripe color could be changed to your brand color. You can have your logo on the report automatically exported. And you sort of can add a cover image. So we've chosen the original image of the church. And we've got now an introduction that's been added. So this is all added as the analysis. And over here, we talk about the fact that the church facade was inspected on 4th of March. It used a number of different aerial images. And there was different. The primary objective is to see how much is the facade deteriorating because of moisture-related issues on the stonework, and then AI was used to actually find dark patches, and all the issues were mild severity. They don't require structural intervention. However, they might require some routine maintenance. And also, it gives us there was 127 square feet of the facade area was covered by these stains. Everything is in generally good condition. but there are some recommendations because we want to make sure that there is some investigations of potential water sources, rainwater runoff, gutters, joints, ledges. Make sure that we have consideration of gentle stone cleaning and a continued periodic drone inspections to track changes in surface condition. So that's the summary. And then we go into the actual quantified bit of the report. And we've got how many images were annotated. And we've got all these dark patches that were observed. We could call them stained patches, perhaps, for better articulation. And they've got 127 square feet. As all of this is automatic from AI, which is brilliant, isn't it? And now you've got all of these different dark patches that we can go into. And so we can look at all the different areas that were marked up, automatically exported into a report. And we can go into the different dark patches, the stained areas. So you've got A1 over here. We can see the stained area. We can see the area. We can see the perimeter. We can see the linear measure. You can see all of these different stained patches that have been, that are now visible, really, in terms of all of the different stained areas that have been identified by AI. And it just makes all of this available in an automatic format so that all of this is documented and captured. And quantified is another big element of it, without having to sort of spend hours and hours quantifying all this and making that drone data that has been captured that much more helpful, that much more useful, that much more actionable. And as I said previously at the start of this video, the use of drone data to be able to actually find all of these different issues and to make the drone data more actionable is what drones have to offer to this industry. So there you have it, folks. That was a quick sort of video, the entire workflow on how you can capture the facade of historic buildings for better maintenance, for preempting issues before they get too severe, and to really utilize drones in the best manner possible and to be able to get really high amounts of value out of them. We hope you found this video helpful. If you did, please do leave us a comment. If you're new to our channel, do subscribe to our channel. We're always interested in having more of a community forming around the channel. And we love hearing from you, any kind of suggestions you might have in terms of the types of videos we should cover next. Do leave them in the chat or get in touch with us at team@hammermissions.com. Thank you so much for listening. We'll see you in the next video for Hammer Missions.